Okay, hi everyone, welcome back to this video series Introduction to Firewalls using PPTP firewall rules as outlined in Table 8.6. The two most common reasons for selecting PPTP as a tunneling protocol are for supporting older Microsoft clients that require tunneling connectivity, or for situations in which a tunnel must pass through a firewall that performs not a tunnel server receiving PPTP connections listens for the connection on TCP port 1723. In addition, PPTP packets are encapsulated using a protocol named Generic Routing Encapsulation, GRE. A GRE packet is identified by its protocol identification number, protocol ID 47. As with ESP and AH packets, no port numbers are associated with the GRE protocol. If you were configuring your firewall to allow PPTP connections to VPN server 1 as shown in figure 8.6, the firewall rules in table 8.7 must be implemented at the firewall. So this is our picture here. So VPN server 1 has the IP address 2323.2.35. Firewall 2323.1.235. VPN server 2, the IP address 172.16.1.211. The firewall has the IP address 39.200.1.2, internet and remote client. So here we go. Firewall filters to access a PPTP tunnel server, PPTP, TCP, any 172.161.211.1723 allow GRE ID 47, any 172.161.211 allow. Using L2TP IPSec firewall rules, the tough part about configuring L2TP firewall rules is that you have to ignore the fact that L2TP is being used. Why, you ask? Because the L2TP protocol is encrypted using IPSec when it passes through your firewall. The firewall is unable to determine what protocol is actually encrypted in the IPSec packets. The L2TP client and the L2TP server establish an IPSec Security Association SA that uses the ESP protocol to encrypt all data transmitted from the client to the L2TP's to the L2TP server's UDP port 1701. The packets are only decrypted after they are received by the L2TP tunnel server. So what do you do at the firewall to allow the L2TP IPsec packets to pass? You simply define the same firewall rules that you use for IPsec. The difference is that you know the endpoint of the tunnel. Table 8.8 shows the rules required to allow L2TP IPsec tunnel connections only to the tunnel server located at the IP address 23.23.2.35. So firewall rules to access an L2TP tunnel server: IKE UDP any 232.3.5 allow. ESP ID any 232.3.5 allow. AH ID 51 any 2323.2.35 allow. If the remote access clients and remote access server support NAT-D and NAT-T, then the firewall can allow IPsec connections to both VPN server 1 and VPN server 2. In this case, the IPsec protocols are encapsulated in UDP packets, thus removing the need for the ESP and AH filters shown in Table 8.8. Table 8.9 shows the firewall rules required to allow L2TP IPSec tunnel connections only to the two internal tunnel servers, NAT -D UDP any 23.23.2.35 500 allow NAT -D UDP any 4500.23.2.354500 allow NAT -D UDP any 172.16.1.211 500 allow NAT -T UDP any 172.16.1.211 4500 allow. At this point, your head is probably spinning from all these rules that you must implement at a firewall for the complex protocols. The bad news is that still more rules exist than you can implement at your firewall. The good news is that the rules are much more logical and definitely easier to digest. At least we think they are tasty. Rather than discussing protocols, the next chapter looks at how a firewall can implement a security policy that restricts who can access the internet and what they can do on the internet, and even limits what hours they can access the internet. So I'm going to leave it here today for this video. Thank you for spending the time with me, and please like, share and subscribe. Thank you.